Good day everyone, we are Tactics. In this video, you will learn continental drift and faulting of rocks. Quarter 2, Module 4, Continental drift and faulting of rocks. At the end of this module, you will be able to Number 1, explain how Ziegler spreads. Number 2, describe the structure and evolution of ocean basins. Number 3, explain how the movement of plates leads to formation of faults, trenches, volcanoes, rift valleys, and mountain ranges. And number 4, describe how layers of rocks or stratified rocks are formed. Learning objectives: A. Describe Ziegler spreading theory. B. Identify evidences that supports the major contentions of the Ziegler spreading theory. C. Explain how the ocean basins evolve. What are its features? D. Describe the movement of plates. And D. Describe how layers of rocks or stratified rocks are formed. Ziegler spreading, a process that occurs at mid-ocean ridges where new oceanic crust is formed through volcanic activity and then gradually move away from the ridge. Harry Hammondess was a professor of geology at Princeton University and became interested in the geology of the oceans. His time as a naval officer was an opportunity to use sonar, also called echo sounding, then a new technology to map the ocean floor across the North Pacific. He published The History of Ocean Basins in 1962, in which he outlined a theory that could explain how the continents could actually drift. This theory later became known as Ziegler spreading. Types of evidences from his theory of Ziegler spreading theory. Number 1. Evidence from multi-material. In the 1960s, scientists found evidence that new material is indeed erupting along the mid-ocean ridge. The presence of these rocks showed that multi-material has erupted again and again from cracks along the central valley of the mid-ocean ridge. Number 2. Evidence from magnetic stripes. Scientists discovered that the rock that makes up the ocean floor lies in a pattern of magnetized strips, hold the record of reversals in Earth's magnetic field. Number 3. Evidence from drilling samples. The Glomar Challenger, a drilling ship built in 1968, gathered the samples. Samples from the seafloor were brought up through the pipes. They found that the farther away from the samples were taken, the older the rocks were. The youngest rocks were always in the center of the ridges. This showed that the Ziegler spreading really has taken place. Ocean basins can be described as a saucer-like depression of the sea. They vary in size from relatively minor features of the continental margin to vast structural deviations of the deep ocean. The largest ocean basins are 3 to 5 km or 2 to 3 miles deep and stretch from the outer margin of the continents to the mid-ocean ridges. There are 5 major subdivisions of the world ocean: the Pacific Ocean, Indian Ocean, Southern Ocean, and Arctic Ocean. The Pacific, Atlantic, and Indian Ocean are conventional ocean basins and are bounded by the continental masses or by ocean ridges and currents. They emerge below 40 degrees south latitude in the Antarctic Circumpolar Current, or West Wind Drift, at the Southern or Antarctic Ocean. In North Polar region, the nearly circular Arctic Ocean, almost landlocked except between Greenland and Europe, is considered the fifth ocean subdivision.
Tectonics. The movement of the plates creates 3 types of tectonic boundaries.
Convergent, where plates move into one another. Divergent, where plates move apart. And transform, where plates move sideways in relation to each other. Convergent boundaries. These convergent boundaries also occur where a plate of ocean dives in a process called subduction. under a landmass. As the overlying plate lifts up, it also forms mountain ranges. Divergent boundaries. At divergent boundaries in the ocean, magma from the deep in the Earth's mantle rises toward the surface and pushes apart two or more plates. Mountains and volcanoes rise along the seam. Transform boundaries. The San Andreas Fault in California is an example of a transform boundary, where two plates grind past each other along what are called strike-slip faults. Fold. In structural geology, it is a stack of originally planar surfaces, such as sedimentary strata, that are bent or curved during permanent deformation. Fourth is a fracture or zone of fractures between two blocks of rock. Folding and faulting. Folding occurs as rocks bend slowly, like road tar softened by the sun. Faulting occurs when rocks break. Folding is caused mainly by compression. Faulting is caused by extreme stress, tension, compression, or shearing. Folds are bends in rock that form when compression shortens and thickens the crust. Faults are breaks in the crust where rock surfaces slip past each other. Rock layers are also called strata, the plural form of the Latin word stratum. And stratigraphy is the science of strata. Stratigraphy deals with all the characteristics of layered rocks. It includes the study of how these rocks relate to time. Stratification in sedimentary rocks may result from changes in texture or composition during deposition. As early as the mid-1600s, the Danish scientist Nicolas Steno studied the relative position of sedimentary rocks. He found that solid particles settle from a fluid according to their relative weight or size. The largest or heaviest settle first, and the smallest or lightest settle last. Slight changes in particle size or composition result in the formation of layers, also called beds, in the rock. Layering or bedding is the most obvious feature of sedimentary rock. Law of superposition is fundamental to the interpretation of Earth's history, because at any one location it indicates the relative ages of rock layers and fossils in them. Steno's law of original horizontality states that most sediments, when originally formed, were laid down horizontally.
This is the end of our lesson. Thank you for watching.